Every time you send a text, load a video, or rely on a GPS map, you interact with an invisible, highly synchronized global infrastructure. Our financial markets, medical devices, and military defense networks are entirely reliant on a steady, uninterrupted stream of processing power. Yet all of that distributed processing power traces back to a highly centralized bottleneck. It narrows down across the Pacific Ocean, straight to a single island roughly the size of Maryland. Most of that global nervous system runs directly through the manufacturing complexes of one company, the Taiwan Semiconductor Manufacturing Company, or TSMC. Geopolitically, this extreme concentration of manufacturing power is known as the Silicon Shield. It acts as a massive economic deterrent against foreign aggression. But that deterrent is currently facing a severe stress test. Taiwan sits across a narrow, heavily militarized waterway, a mere 160 kilometers from the coast of mainland China, a nation that has explicitly vowed to absorb the island by force if necessary. The modern world's most critical supply chain is physically anchored squarely inside one of the most volatile borders on Earth. To grasp why other nations cannot easily replace Taiwan, we have to look at the scale of their operation. Taiwan owns the absolute baseline infrastructure required to make modern electronics function. This chart shows the global contract chip market. TSMC commands 73. These specific chips are the only hardware capable of training advanced artificial intelligence models. Creating those circuits requires the most precise manufacturing environments ever built. Wafers are processed in specialized clean rooms, where a single microscopic speck of dust can ruin millions of dollars of hardware. If operations inside those specific rooms shut down, the entire global pipeline for artificial intelligence and advanced computing completely stops. These factories are exceptionally fragile. They require a flawless, uninterrupted power grid, massive amounts of ultra-pure water, and extreme physical stability to keep their machinery calibrated. Because of that extreme fragility, paralyzing production doesn't even require a direct missile strike. A severed undersea internet cable, a sudden power grid failure, or a partial naval blockade preventing raw materials from reaching the ports would instantly shut the fabs down. Experts model this exact scenario under a term called the trillion-dollar blackout. This map illustrates the immediate global fallout. A complete halt in Taiwanese manufacturing would drain an estimated $2.5 trillion from the global economy every single year. Assembly lines for automobiles would freeze, data center expansions would stall out, and consumer electronics would stop shipping entirely. But that blackout zone includes the attacker. China relies heavily on these exact same Taiwanese processors to run its own domestic tech sector and to advance its military hardware. That deep vulnerability is Taiwan's strongest armor. Taking the island by force guarantees the total destruction of the very infrastructure the attacker needs, ensuring mutually assured economic collapse. Recognizing this massive geographic liability, Western governments are now desperately attempting to completely untangle their supply chains from the strait. Nations like the United States and Japan are spending tens of billions of dollars to build their own localized fabrication plants, attempting to physically bring TSMC operations onto their own soil to decentralize the risk. However, capital alone cannot solve the problem. Replicating this specific ecosystem requires decades of specialized labor training, deeply integrated local suppliers, and massive power infrastructure. It is a slow, methodical process that cannot be rushed. So, for the foreseeable future, the physical limits of modern technology remain tethered directly to the shifting borders of international politics. The entire global economy is locked in a tense waiting game, built solely on the hope that the Silicon Shield is never tested.